Welcome to another episode of Terry's Notes, and today we are going to be looking at the second video on the mole concept. And in this video we are focusing on solutions and titrations. Now, the concentration of a solution is usually expressed as mole per dm cube or gram per dm cube. All right, what this is telling us is how many moles are present in 1000 cm cube of solution. All right, so you need to know that 1 dm cube is equal to 1000 cm cube. Right, this is important. Okay, so in this example here, we have to calculate the concentration in mole per dm cube of the following solutions. So in the first example, we have 60 grams of sodium hydroxide in 750 cm cube of solution. Okay, and let's go to the solution. Okay, so we have 60 grams of sodium hydroxide being dissolved in 750 cm cube of solution. First thing we need to do, we need to calculate the relative formula mass of sodium hydroxide. So we get the mass numbers from the periodic table. Sodium is 23, so we have one sodium atom, so therefore we have 23. We have one oxygen atom, that is 16. We have one hydrogen atom, that is 1. We add this up and we get 40. Okay, and what does that tell you? That tells you that the mass of 1 mole of sodium hydroxide is 40 grams. Okay, what we need to do is to find out how many moles of sodium hydroxide does 60 grams give us. So we know that 40 grams of sodium hydroxide contains 1 mole. Therefore, 60 grams of sodium hydroxide contains, again, we wrote our statement properly, so it will be 60 multiplied by 1 divided by 40, and that gives us 1.5 moles. So notice the first thing we had to do is to find out how much moles are present in 60 grams of the sodium hydroxide. Now, 60 grams was dissolved in 750 cm cube. So 750 cm cube contains 1.5 moles of sodium hydroxide. Therefore, remember, concentration is given as mole per dm cube, and 1 dm cube is 1000 cm cube. So we need to find out for 1000. So we take 1000 and we multiply by 1.5 divided by 750, and that gives us 2 moles of sodium hydroxide. All right, therefore the concentration of the sodium hydroxide is 2 mole per dm cube. Notice how we wrote it: mole dm minus 3 to the power minus 3. The second part of the question had asked for the concentration of a solution containing 80 grams of sodium carbonate in 800 cm cube of solution. So like in the previous example, we need to find the relative formula mass of sodium carbonate. So sodium, the mass number is 23, but we have 2 sodium atoms here, so it's 2 by 23. We have 1 carbon atom, the mass number is 12. We have 3 oxygen atoms, so therefore, and the mass number of oxygen is 16, so it's 3 multiplied by 16. We add this up and we get 106. What does that number tell you? It tells you that the mass of 1 mole of sodium carbonate is 106 grams. So write our statement as 106 grams of sodium carbonate contains 1 mole. We need to find out how many moles are present in 80 grams. So 80 grams of sodium carbonate contains, cross multiply, 80 multiplied by 1 divided by 106, and that gives us 0.755 moles. Right? So all we've worked out here is how many moles are present in 80 grams. This amount of moles has been dissolved in 800 cm cube. So therefore, 800 cm cube contains 0.755 moles of sodium carbonate. Therefore, 1000, because remember, concentration is mole per dm cube, and 1 dm cube is 1000 cm cube. So we cross multiply 1000 multiplied by 0.755 divided by 800, and that gives us 0.943 moles of sodium carbonate. Therefore, we write the concentration as 0.943 mole per dm cube. Okay, another type of mole question that can be asked is to calculate the percentage composition of an element in a compound. For example, calculate the percentage of nitrogen present in the fertilizer ammonium nitrate. The formula for ammonium nitrate is NH4NO3. Now, what we need to do is to find the mass of 1 mole of ammonium nitrate. We do this as usual. We have 1 nitrogen atom at the beginning here, so we have 14. We have 4 hydrogen atoms, so it's 4 by 1. We have 1 nitrogen, so we add another 14, and we have 3 oxygen, so it'll be 3 by 16, and that gives us a total mass of 80 grams. Okay, so the mass of 1 mole of ammonium nitrate is 80 grams. What we need to do is to find the mass of the nitrogen present in 1 mole of ammonium nitrate. Now, when we look at the formula for ammonium nitrate, we have 1 nitrogen here and we have 1 nitrogen here. So therefore, we have 2 nitrogen atoms present. So therefore, the mass of nitrogen present in 1 mole is 14 plus 14. That's to take into account the 2 nitrogen atoms, and we get 28. So the percentage of nitrogen present in ammonium nitrate will be 28 divided by 80, because 28 is the mass of nitrogen present in 1 mole, and 80 grams is the mass of 1 mole of the fertilizer, and we multiply by 100 because we are dealing with percentages, and we get 35%. Now, another type of question that can be asked is to calculate empirical formula. So in this example, we have a substance that has the following composition by mass. It has 40% carbon, 6.66% hydrogen, and 53.34% oxygen. And they told you the relative molecular mass of the substance is 180. Calculate the empirical formula of the substance and the molecular formula. Now, the empirical formula is simply the simplest whole number ratio of the atoms present in the substance, right? So we have carbon, hydrogen, and oxygen. So the first part of the question is simply asking, what is the simplest whole number ratio of the carbon, hydrogen, and oxygen present in this substance? Now, the easiest way to do this problem is to drop a little table, and we have carbon, hydrogen, and we have the oxygen. And what we need to do is to first write it down like this. We need to write down the mass in 100 grams. Now remember, in the question it said 40% carbon, 6.66% hydrogen, and 53.34%. Usually when they give you the percentages, the first statement is to write down the mass in 100 grams. All we do is remove the percentage sign. So it'll be 40 grams, 6.66 grams, and 53.34 grams. And the next thing we do, we write down the relative atomic mass. Carbon, relative atomic mass is 12, hydrogen is 1, and oxygen is 16. Your next step is to divide by the relative atomic mass. So it'll be 40 divided by 12, and that gives us 3.333. We take 6.66 and divide by 1, which will give us 6.66. And we take 53.34 and divide by 16, and that gives us 3.334. Now, when we get these numbers, the next step is to divide by the smallest of the numbers. If we look at the numbers, we see that the smallest number is really 3.333. Okay, this one is 3.334, which is roughly the same figure. So we'll go with the 3.33. So we take 3.333 and divide it by 3.333, we get 1. 6.66 divided by 3.333, we get 2. And 3.334 divided by 3.333, we get 1. So therefore the empirical formula for this substance, we write it as CH2O, because we got 1 as a carbon, we got 2 for the hydrogen, and 1 for the oxygen. So the simplest whole number ratio is 1 to 2 to 1. And we write this as CH2O. Okay. The next part of the question asks for the molecular formula. Now, once you have the empirical formula and they give you the mass of 1 mole of the substance, calculating the molecular formula is very simple. What you do, you write a statement like this. We say N multiplied by the empirical formula is equal to 180 grams. Because remember, the empirical formula is just the whole number ratio. It is not the actual molecular formula. So CH2O, we work that out. We have 1 carbon, that is 12. We have 2 hydrogen, so it's 2 by 1. I have 1 oxygen, so that is 16. And that is equal to 180. So if we work this out, we get N multiplied by 30 is equal to 180. Therefore, N is equal to 180 divided by 30, and that gives us 6. So what we've just done is worked out the value of N. So therefore, the molecular formula, all we have to do is multiply each of the numbers at the bottom here by 6. All right, so it'll be C6. We have 2 hydrogen, so it'll be 6 by 2, which gives us 12. O, oxygen, we have a 1 here, and therefore it's 1 by 6. So the molecular formula is C6H12O6. Okay, so just remember these steps. Now, something that you need to understand is, what does an equation tell you? Okay, you need to understand mole ratios within an equation. Now, in this example, we have calcium carbonate reacting with hydrochloric acid to give us a salt, which is calcium chloride, carbon dioxide, and water. Now, the equation as it is right now is balanced, right? Just simply by putting a 2 in front of the hydrochloric acid. So we don't have a number in front here, so we will assume it is understood that it is 1. So we have 1 mole here, we have 2 moles of acid, we have 1 mole of calcium chloride, 1 mole of carbon dioxide, and 1 mole of water. In terms of masses now, the mass of 1 mole of calcium carbonate is 100 grams. And this is the calculation for it here. Hydrochloric acid, mass of 1 mole of hydrochloric acid is 36.5. In the case of the calcium chloride, it's 110. Carbon dioxide is 44, and water is 18. So just by looking at we've written this equation in 2 ways. Looking at it as moles and looking at it as mass. So in terms of moles, we can say that 1 mole of calcium carbonate reacts with 2 moles of hydrochloric acid to produce 1 mole of calcium chloride, 1 mole of carbon dioxide, and 1 mole of water. We could also say that 1 mole of calcium carbonate produces 1 mole of calcium chloride, or 1 mole of calcium carbonate produces 1 mole of carbon dioxide. So all of that information can be found directly from your equation. And in terms of masses, we can say that 100 grams of calcium carbonate produces 110 grams of calcium chloride. We can also say that 100 grams of calcium carbonate produces 44 grams of CO2. And we can also say that 100 grams of calcium carbonate produces 18 grams of water. And that is in reference to this particular equation. Okay. Now, in this question, we have 2 grams of calcium carbonate being added to 40 cm cube of hydrochloric acid of concentration 2 mole per dm cube. Now, this is a typical examination question. And in this question, we are assuming that we are dealing with RTP. And we know at RTP, 1 mole of a gas occupies 24 dm cube. First part of the question asks to write a balance equation for the reaction. Okay, so calcium carbonate plus hydrochloric acid produces calcium chloride and carbon dioxide and water. You're adding a carbonate and an acid. We expect to get a salt, carbon dioxide, and water. And we have to balance the equation as well. Now, the second part, part B, asks to calculate the number of moles of calcium carbonate in 20 grams of calcium carbonate. So, the first thing we do, we find the relative formula mass of calcium carbonate. So, calcium mass number is 40, carbon is 12. We have 3 oxygen, so it'll be 3 by 16, and that gives us 100. This tells us that 100 grams of calcium carbonate contains 1 mole. And the question asks for 20 grams. Okay, I made a slight error here. It should have been 2 grams. So it'll be 2 multiplied by 1 divided by 100, and that'll give us 0.02 moles of calcium carbonate in 2 grams. It's a typo in the question. The part C asks for part C asks for to calculate the number of moles of hydrochloric acid in 40 cm cube. Okay, so the concentration of the acid was 2 mole per dm cube. So we can say that 1000 cm cube contains 2 moles of acid. Therefore, 40 cm cube contains, and we cross multiply, 40 by 2 divided by 1000, and that gives us 0.08 moles of acid. And then the part D of the question asks for what is the limiting reagent. Now, this is the limiting reagent is your reagent that is in the smaller quantity. If you look at this question here, we have 0.2 moles of calcium carbonate, but we have 0.08 moles of acid. So 1 mole of calcium carbonate reacts with 2 moles of hydrochloric acid. Okay, so 0.02 moles of calcium carbonate reacts with 0.02 multiplied by 2, which gives us 0.4 moles of hydrochloric acid. So the calcium carbonate is in the smaller amount, which is 0.02 moles, and it will only react with 0.04 moles of the acid. This means that the acid is in excess. So therefore, the calcium carbonate is our limiting reagent. So your limiting reagent is the one that is in the smaller quantity. And part E asks for the theoretical volume of carbon dioxide that can be obtained at RTP. We know that 1 mole from the equation, 1 mole of calcium carbonate produces 1 mole of carbon dioxide. And since we are dealing with RTP, 1 mole of calcium carbonate will produce 24 dm cube of carbon dioxide. So therefore, 0.02 moles will produce 0.02 by 24 divided by 1, which gives us 0.48 dm cube of carbon dioxide. In this next question, we're dealing with a titration. We have 25 cm cube of sodium hydroxide is required 25 cm cube of sodium hydroxide required 23 cm cube of hydrochloric acid of concentration 1 mole per dm cube for neutralization. First part, write an equation for this reaction. So NaOH plus HCl produces NaCl plus water. If we have a base plus an acid, it gives us a salt and water. And if you look at the equation, it is already balanced. So part B, the first part asks to calculate the number of moles of hydrochloric acid in 23 cm cube. So 1000 cm cube contains 1 mole of hydrochloric acid. Therefore, 23 multiplied by 1 divided by 1000, and that gives us 0.023 moles of hydrochloric acid. And the second part, B part 2, asks the number of moles of sodium hydroxide in 25 cm cube. Now, from the equation, we know that 1 mole of hydrochloric acid reacts with 1 mole of sodium hydroxide. Therefore, 0.023 moles of hydrochloric acid must react with 0.023 moles of sodium hydroxide. Okay. Now, this is sodium hydroxide reacting with hydrochloric acid is a 1-to-1 ratio. You can get questions where the mole ratio is not 1-to-1, and you may need to multiply by, let's say, if the mole ratio was 1-to-2, you might have to multiply by 2. So you always have to go back to your equation. Okay. Now, this is a typical examination question, especially in the data analysis question. And the last part, determine the concentration of the sodium hydroxide in mole per dm cube. Now, we know that 25 cm cube of the sodium hydroxide contains 0.023 moles. We need to find out how many moles there are in 1000 cm cube. So 1000 cm cube, cross multiply by 0.023 divided by 25, and that gives us 0.92 moles present in 1000 cm cube of the sodium hydroxide. So the concentration of the sodium hydroxide is written as 0.92 mole per dm cube, as in 0.92 moles of the sodium hydroxide is present in 1000 cm cube. So in a titration, you have to find the concentration of an unknown substance. So in this question, we had to find the concentration of the sodium hydroxide. The concentration was unknown. The concentration of the hydrochloric acid was known as 1 mole per dm cube. Okay.